Let's go to page 65 and start with number 87. This one you're looking for the GCF of 36, 27, and 45. Okay, so 36, 27, and 45. Now to look for GCF, we're going to just go and divide. So to start with 2, so cannot. So 3, yes. So you can all this can divide by 3. You got 12, 9, and 15. And you can divide by 3 again. So you get 4, 3, and 5. So GCF would be the numbers, the factors on here. So in this case, GCF equal to 9. Okay, let's go to 88. So it says, how many multiples of 7 are there between 100 and 200? So you're going to 100 to 200. So how many 7s are there? So what you need to do is, you need to go ahead and also figure out from 1 through 99. Okay? And figure out from 1 through 200. So 99 divided by 7 . So there are 14 over here, okay, and then 1 through 200. Okay, so there are 28 over here. So from 1 through 200, there are 28 numbers. From 1 through 99 is 14. So that means you subtract, so you're going to get 14 right over here. So answer would be 14. Okay. So again, you always have to start from 1. And since you start with 100, you have to figure out how many are in here. And then you figure out from here to here, and you can subtract to get this part. So this is one of the very important technique. Okay, let's go to 89. So you have 19 to 1993, and you're looking for the unit digit. Okay, so unit digit. So 9 to the 1 power is equal to 9. 9 to the 2 power equal to 81, so it would be 1. Okay, and so from here you can see that 9 to the 3 power equal to 9. So you're going to cycle of 2. So that means this is going to be equal to 19 to the cycle 2 to be 19 to the 1, and so the last stage would be 9. Okay, let's go to number 90. Okay, so you're looking for the 1,275 times. So you're looking for T1275, and you have this here. You got 1, 3, 5, dot 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 dot. To 15, 1, 3, 5, dot, 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 to the 15, and so forth, okay? So again, what you want to do, you want to figure out the cycles, right? So this is 1, 3, 5, 7, 9, 11, 13, 15, okay? And after that, it repeats again. So there's a cycle of 8. So this is a cycle of 8. So 1275, you kind of minus the multiple of 8. So minus 800, so that's an easy way to do it. Okay, and you're minus 400 because 400 is the multiple of 8, right? And you can minus 72. Okay, so 3. So the T1275 is going to be equivalent to congruent to T3. So T3, the third term would be 5, okay? And so the answer would be 5. Okay, let's go to 91. 91, it says, find the smallest positive integer such that when you divide by 10, it leaves a remainder of 9. So after you read through, what you need to do is you're going to tally all your information. So let n equal to the number. So it will, when divide by 10 leaves a remainder of 9. So that means it's 9 mod 10, right? Divide by 10, you have remainder of 9. and remainder of 8 divided by 9. Okay, and so forth. So you get 6 mod 7, again divide by 7, you get the remainder of 6. 5 mod 6, and 4 mod 5, 3 mod 4, 2 mod 3, 1 mod 2. Okay? So again, so you have a number, divide by 10, you get remainder of 9, divide by 9, remainder of 8, divide by 8, remainder of 7, and so forth. Okay? So what would be the n equal to? Now the way to do this is that the trick is you want to add or subtract a number so that it will equal to 0 or 1, or so you have the same number. Okay? So what you want to do, if you add 1, so n plus 1, this will give you 0 mod 10. So the trick is try to get this remainder the same. Okay? And so you're going to get 0 mod 9, 0 mod 8. Because when you plus 1, this becomes 10, so the remainder is 0. When you add 1, it becomes that, right? And so this becomes 0 mod 7, 0 mod 6, 0 mod 5, 0 mod 4, 0 mod 3, 0 mod 2. Okay? So in other words, this number, okay, divide by all this have remainder of 0. That means this is a least common multiple of all these. Okay? Okay. So that means n plus 1 equal to LCM of 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now all we have to do is find this, right? Now, when you're doing this multiple, okay, so notice 8 is a multiple of 2 and 4 already, so you can kind of don't even have to worry about that. 10 is a multiple of 5, so when you consider 10, you don't need a 5. This is a multiple of that, so you don't even have to worry about a 3. So now all you have to do is it becomes this part right over here, okay? So to find the LCM, okay, remember the trick, so you got 6, 7, 8, 9, 10, right? So when doing the LCM, as long as two numbers can divide, you can divide already. So if you divide by 2, you get 3. Now if you cannot divide, you leave it alone. Okay? So again, if you can divide, you divide. If you cannot, then just leave it. Okay? So that take it to 2. Now you can do the 3, right? Remember, this is only for LCM, right? So divide by 3, you get 1, 7, 4, 3, 5. And that's it. So you just multiply all this together. Now when I multiply this, I like to, you can use your calculator, okay? It's quicker. But if you don't have a calculator, or if you're not allowed calculator in the tournament, in the competition, then what you want to do, you want to multiply make into a 10. So this is a 10, okay? And try to even out, so try to make the biggest number with the smallest number. So this would give me 21, and this would give me 12, okay? And you can multiply this together, so 21 and 12, so it give you 252, okay? And then times by 10 will give you, so times by 10 will give you 2520. So n plus 1 equal to 2520, okay? So now all you have to do is minus 1 on both sides, so n equal to 2519. Okay, and that's the number. Okay, so again, the trick is try to get all this. Does not have to equal to 0. Sometimes it can be 1. So it depends on the situation. So you want to add or subtract a number so that your remainder will be the same. And that way you can look up the LCM, and that way you can go and add or subtract to get the n.